students, today we are going to discuss geometrical isomerism. It is a very important part of isomerism, especially unsaturated compounds. So this type of isomerism based on the arrangement of atoms and groups across double bond shows geometrical isomerism. It is also called as configurational isomerism, where the structure differ from one another due to arrangement of atoms and groups across carbon-carbon double bond. This is called configurational isomerism because it has a restriction for the free rotation of carbon-carbon double bond. That's why it is called also configurational isomerism. It is a part of configurational isomerism. Configurational isomerism because it has restricted for the free rotation of carbon-carbon bond. That's why it is called configurational isomerism. And this isomerism mainly observed where the molecule having carbon-carbon double bond. So across carbon-carbon double bond, the arrangement of atoms and groups differ from one another. On the basis of arrangement, it has mainly geometrical isomerism, mainly two types of isomerism. That is, one is called cis isomerism, cis isomer. Another second one is trans isomer. Cis isomer and trans isomer. Cis and trans, these two are the main part of geometrical isomerism. Cis isomer indicates when the atoms, same atoms are the same side. Similar atoms in the same side. If similar atoms in the same side, that is called what? Cis isomer. Trans isomer means similar atoms in the opposite side. Opposite side, that is called trans. Trans isomer is also called anti. That is also called anti isomer. Let us discuss the examples of cis and trans isomer. If you give the numbering 1, 2, 3 and 4, that is, it is 2-butene. This is 2-butene, 2 cushion carry double bond, and if you see the arrangement across double bond, we have to think that each carbon atom of double bond must contain two different groups. Here hydrogen and methyl. Here hydrogen and methyl, both are different. So here if you see the arrangement, if both hydrogen of one side of double bond, that's why it is called cis. It is called cis isomer. Just if you change the groups around one carbon. So keep the other position intact without changing this one. Here H and CH3 will be interchanged, CH3 and H. If you see, only you have to change only one carbon. If you change both carbon, then same type of isomer will be formed. Same type of configuration will form. That's why here HCH3 will be interchanged. Then this as methyl and hydrogen, if you see hydrogen and methyl, these similar groups are in opposite sides. That's why it's called trans. Trans isomers. It is called trans. So cis isomer and trans isomers. Let us take another example. This is called cis. Cis. How it will be trans? You keep this one position intact, only change other carbon. H will be this side and bromine will be this side. So it is trans. Opposite sides, H in opposite sides. That's why it is trans. And this is cis. So these are mainly when the atoms and groups attach to double bond, if both are same, if you are considering the similar atoms, arrangement of similar atoms across carbon-carbon double bond, then you can tell which is cis and which is trans. But if, second case, if all atoms or groups are different, if all are different, for example, you take C, here H, here Br, here Cl, here I. Here if you see, here all are different. We cannot say which is cis, which is trans. So that the cis-trans isomerism nomenclature, cis-trans isomerism cannot be studied in this case because all are different. We cannot tell which will be in one side, which will be in different side. So all are different. It will follow the one important rule, that is Ingold and Prelude rule. Calm, Ingold and Prelude rule. It will follow Ingold and Prelude rule. What is that rule? This rule states that the groups attached to the particular carbon will be given priority order. That is, priority order will be given. Priority order. Priority order means which has higher atomic mass, which has higher atomic number. First will be given atomic number, which has higher atomic number will be considered as a higher priority, which has a lower priority, which has a lower atomic number considered as a lower priority. So, and it will be written as higher priority will be taken as A and lower priority will be taken as B. For higher priority will be considered as A and lower priority atom or group considered as B. For this case, if you can tell, so this is the in between H and B here, R it is smaller, it is the atomic number 1, it is atomic number how much? 80. Like this. So as atomic number of bromine is greater, so it is A. And smaller B. Similarly between chlorine and iodine, greater A, smaller B. So you see now the arrangement. If BB, this is also B, this is also A. So BB in one side and AA in one side. So it is called same side, that is called Jusamen. Z. Z indicates Jusamen. The nomenclature is Jusamen. Jusamen. Single Jusamen. Jusamen means that is same side. That's why that is called Z. Instead of cis, we have to write Z. Z means when the groups are in same side. Here group means here higher priority or lower priority. If lower priority in same side or higher priority in same side, that is called Z. Z means that is the cis. Another rule, if you just change it, if you change this one, C, and here bromine, here H, then this will be A and this will be B, and previous remains same, Cl and iodine. This is A, this is B. Here you see B, B, A, A in opposite sides, that is called E. E means antigen. E, N, T, antigen. E, N, T, G, G, N. Antigen. Antigen means it is opposite. So anti means opposite. A opposite, B, B opposite. That is just like trans. But cis trans only is applicable when the groups will be similar. When the groups will be similar atom one side, that is cis. Similar atom opposite sides, that is trans. But here, when all are different, then we have to follow Ingold and Prelog rule, that is priority order rule. Higher atomic number, higher atomic mass will be considered as higher priority order, that is A, and lower will be considered as B. But we have some cases we have to follow, some rules we have to follow. That if double bond groups are there, if C double bond C is there, it is considered as a 2C. If C triple bond C is there, it is considered as 3C. C double bond O considered as CO. Like that means if double bond is there, it will be considered as a 2 atoms. If triple bond is there, considered as a 3 atoms. So that automatically the priority order will be increased. So this is the some case. We can take one examples for this. Here we can see left side, you see chlorine, higher atomic number A, then carbon, methyl B. Here you see carbon attached to carbon, here carbon attached to carbon, but this carbon attached to one directly, but this is double bond means this considered as a C. Already I have told you double bond means C attached to CC. Here C attached to 2C, direct C attached to 2C because double bond. But here direct C attached to 1C. So it will be A, it will be B. So you have to see, you have to think like this. If double bond is there, then the double bond means the same atom will be repeated. That means similar type of bonds are there. So C double bond C means C single bond C and C single bond C. That means 2C attached to C you have to consider. That's why it will be A. Here C attached to 1C, here C attached to 2C. That's why it is A, this is B. As it is greater atomic number A and the smaller atomic number, that is B. So this is as B one side, A one side, that is Z. This isomer is called Z. So Ingold and Prelog rule is applicable in the case where the atoms and groups attached to double bond all are different. When all are different, then cis-trans isomerism is not possible. But in place of cis-trans isomerism, we can give EZ notation. That is using Ingold and Prelog rule. That is priority order. Greater atomic number, that is A. Smaller atomic number, that is B. If atomic number has, for example, C, suppose here D, here H, here carbon 14 attached, here carbon 12 group attached. For example, here this carbon both are same. Here this carbon is 14 carbon, this carbon is carbon 12. But here atomic number of both carbon is same. But when atomic number is same, you have to consider the mass, atomic mass. Here 14, that means A. Here 12 means that is B. Here D, isotopes. We can say isotope. When you use isotopes, then greater atomic mass will be considered as A. Here D will be A, H will be B. Here A one side, B, that is your Z. Like this we can give. So you have to consider what are the arrangement whether atomic number will first we will take the preference atomic number, then when atomic number is same, then atomic mass, then first you concentrate the first bonded atom. If first bonded atom same, then the next bonded atom. You have to follow this rule. So that is called your priority order rule, that is in bold and regular rule for giving EZ notation. Then what are the properties? Properties is very important, that a cis isomer has greater polarity than trans isomer. Polarity is greater because will not cancel. Just you see cis isomer, for example, this case what happens? The polarity is opposite, that is not cancelled. Here if A or B in opposite side, then one direction will be cancelled by other. So cis isomer has more polar than trans isomer, and polarity, this is polarity, and cis isomer has greater boiling point than trans isomer, that is BP. Because polarity is more means boiling point is more. But trans isomer has greater melting point than cis. This is your melting point. Why trans isomer is greater melting point? Because trans isomer, if you see this one, this case trans isomer, or you can say particularly cis trans, properties of cis trans, cis and trans. In case of cis trans, where the atoms and groups are similar, then we can see cis trans. Cis trans case, cis isomer has greater polarity, so greater boiling point. As trans isomer, more symmetrical. Trans isomer is more symmetrical. Symmetrical structure, so close packing is better. That's why trans isomer has higher melting point than cis isomer. So this is regarding melting point, boiling point, and polarity, and also stability. If you see that cis isomer generally unstable, stability. If you see cis group is bulkier group is there, then cis isomer is less stable than trans isomer. That is stability. This case consider when the groups attached to the double bond, the larger group, bulkier group is there, then cis isomer is less stable than trans isomer due to spherical repulsion. If you see the same group are there, if the bulky group are there, then it undergo a repulsion. Due to the repulsion, the stability decreases. So these are some important property of the geometrical isomers and the classification of geometrical isomers. I can give EZ notation, I can which isomer is cis isomer, which isomer is transisomer, some basic concept we discussed. So you practice it, and any doubt you can interact later. Okay, thank you.